Hey guys, welcome to another math video. So for this video, I will be talking about domain and range. Okay, so let's just jump right in. This is what I'll be talking about, like I mentioned. Pretty straightforward. Okay, so domain, in general, talks about all of our x values. So on a number line or on the Cartesian plane, that's all the values left to right. Okay. When we talk about the range, that's all of our y values. So on the Cartesian plane, that's all our values going up and down. Okay? Or vertical, I guess. Okay, so before we actually get into finding the domain and range, we gotta go over some basic notations for domain and range. So there's a couple of ways we can actually write out domain and range. The first way is interval notation, and when you get into the higher level math, like pre-calculus, trig, calculus, all that stuff, this is actually the way that a lot of people prefer to use because it's a lot shorter to write. So some of the stuff they use are brackets, and we use brackets when the value is included. And I know this one doesn't make any sense right now, especially if you have never seen it before, but it'll make more sense once we get to the example. Okay, the other type of notation we use is brackets. Well, I'm sorry, parentheses. And we use parentheses when the value is excluded. Again, it'll make more sense in the example. And we also got infinity. Now, infinity, no matter what, always gets parentheses. So that's the easiest one to remember. Okay, now the other way we can do, we can write out the solutions for domain and range, or write out domain and range, is by using set notation. And set notation looks like this. It looks a bit confusing here. So generally, you don't put all these symbols here like this. You just choose one. Okay, and this is read x such that, that's what this vertical line is, such that x is, it's either going to be greater than or equal to, less than or equal to your constant, whatever that is. Okay? And like I said, this will make more sense once we get into the examples, so let's go ahead and jump right in. Okay, so here is a horizontal axis, which means this is probably an x-axis, so we're going to be finding the domain. So here we have an open circle at 4, which means 4 is not included in our answer, and it continues all the way to the right. It doesn't stop, keeps going all the way to the right. So in interval notation, we always go from smallest value to largest value. So in this case, our smallest value is 4, and our largest value is positive infinity because it keeps going indefinitely to the right. So when we write interval notation, it'll look something like this, where we start at 4, because that's our smallest value. And there's an open circle at 4, so 4 gets a parentheses. Our largest value is infinity, and remember, infinity always gets a parentheses. Okay, so set notation for this is going to be slightly easier because all you're basically doing is you're turning this graph into an inequality, and it should look something like this. Right? So x such that x is greater than 4. That's pretty much all it is. Okay, so let's take a look at another example here. Okay, so this time we have a closed circle here at 3, and it's going indefinitely to the left, which makes 3 our largest value. So in this case, our smallest value is negative infinity, so when we do our interval notation, it'll look something like this. So smallest to biggest, so negative infinity, remember, always gets a parentheses no matter what. 3 is our larger value, and since there's a closed circle at 3, 3 gets a bracket. Okay, set notation is going to be slightly more simplistic because, again, we're just turning this graph into an inequality, so it should look something like this. X such that x is less than or equal to 3. Alright? Hope that was pretty straightforward. So let's take a look at another example here. So now this time we have our Cartesian plane, so we got an x and y, which means this time we're going to be doing both domain and range. Okay, so we'll start with the domain first. So that's what we've been doing this whole time. That's all of our x values, so everything left to right. So you can see the arrows here. They tell you that the graph keeps going. So it keeps going to the left, keeps going to the right, which makes our smallest and largest values infinity. So interval notation should look like this. Negative infinity to infinity, and you remember, infinity always gets parentheses. That's why both of these have parentheses. Okay, now set notation will look something like this. And it won't always look like this. It really depends on the textbook that you're using. They'll tell you to write different things. But generally speaking, it'll look something like x, such that x is all real numbers, because in this case, the graph is hitting all of the x values in both directions. So x is going to be any number, really. Any real number. Okay, so now let's take a look at the range. So the range is going to be your y values, everything up and down. Okay, so the arrow tells you it keeps going up, and it dips down to here, -3. There's no open circle at -3, which means -3 is part of our answer, so when we write our interval notation, it should look something like this. And remember, smallest to biggest, -3 to infinity. Since -3 is included, it gets a bracket. Infinity always gets a parentheses. Okay, now set notation is going to be like our last couple of examples, where all we're doing is we're just creating an inequality. So it should look something like this. Y is such that y is greater than or equal to -3. So starting at -3 keeps going up. Basically, is all that's saying. Okay, let's take a look at another example here. Okay, so this time, there's no arrows on the ends of the graph, so I'm just going to tell you that the graph goes on infinitely in both directions. Okay, that'll really help with coming up with the domain for this. So remember, domain is your x values, and there's an open circle here when x is equal to 1, which means we're not including 1 in our answer, because open circle means it's not included. So our interval notation will look something like this, and you haven't seen this yet, so I'm introducing this to you now. Negative infinity to 1, union, this u is union, 1 to infinity. And since there's an open circle at 1, 1 gets parentheses. Infinity always gets a parentheses, and this union tells us that there's a break in between. So it goes from negative infinity to just right before 1, so like 0.9999999, whatever. And then after 1, so 1.00000000001, or however many the zeros you want to add in there, to positive infinity. Okay, so the set notation is going to be slightly easier, because all we're doing is we're excluding 1. So we want all the x's except when x is equal to 1. So we have x such that x is not equal to 1. Okay, now let's take a look at the range. So the range is going to be similar to do in interval notation and set notation. The difference is that this time we're looking at the y values, so the up and down line, not the one left to right. Vertical, not horizontal. Okay, so that's where a lot of people get hung up on. So in this case, the graph does not exist when y is equal to 0. Okay, so that's the number we're excluding this time, because we're looking at the range. Set notation would be similar to the domain, where we're just excluding 0. So y such that y is not equal to 0. Okay, so that's the thing you have to pay attention to when you're doing range. You have to change your orientation, because now we're going up and down instead of left to right. Okay? Alright, so for this one, we have two distinct endpoints, so we're not going to infinity in either direction. So taking a look at the domain, so again, it's our smallest x value to our largest x value. So our smallest x value is -3, largest is 8. So our interval notation should look something like this. Okay, so there's an open circle at -3. So at -3 gets the parentheses, and there's a closed circle at 8. So 8 gets the bracket. Okay. Now when we do the set notation is going to have a compound inequality. Okay. Because everything in between exists. So x such that negative 3 is less than x is less than or equal to 8. So this is just basically saying x is in between negative 3 and 8 and can include 8. Okay? Otherwise, you'd have to write two separate inequalities. X is greater than negative 3 and x is less than or equal to 8. But it's simpler to just kind of put them together. Okay, so let's take a look at the range. So unfortunately, the range doesn't happen on some nice numbers, so these aren't exact values that I use, they're estimates. Okay, so taking a look at our y values, our interval notation looks like this. I said the smallest y value was negative 4.8 and the largest was 2.4, and that's kind of eyeballing it because, well, there's no real scale to use, so I just kind of eyeballed it there. Okay, so again, negative 4.8, thereabouts, there's an open circle, so we use the parentheses. 2.4, there's a closed circle, so we get to bracket. Okay, now, the set notation is going to be similar to the domain where we do a compound inequality, and it's basically that, really. So, I hope that made sense. I know the previous example was a lot more confusing, but I hope this one made more sense. Alright, so that's pretty much it for this video. That's what we did for this. Stay tuned for my next video. Should be coming out soon. And thanks for tuning in. I'll catch you next time. Take care.